Good morning, folks. So we're going to continue where we left off in last video in my Data Science for Paleontologists series, where we did some data prep and worked through some loops and functions, and we're going to continue both of those trends with some external data processing. So I figured we'd start by explaining how to get some data. So this is the Neotoma Explorer, which is a GUI for the Neotoma database. That is, our lab is part of this, so this is the database we use most often. And when you get onto the Neotoma Explorer website, you can search for data. In this case, it's data amoeba surface samples. And here I've found a data set from southern China. So we're going to take a look at it, and I've already downloaded it and saved it as an Excel file. Now, that's not too bad, but it contains a lot of unnecessary information, and it's not in tidy data format. So let's just work to change it into tidy data format. So we're going to start by highlighting everything. Control copy. I like to skip a line so it's easy to tell it apart. And then we're going to go up here to paste, paste special, transpose. And now it is in a format that we can use. So let's delete this part. Don't need that anymore. We can delete our gap line. Delete, shift cells up. Oops, forgot to do it to this side too. Okay, now let's see here. More or less, all of this information is useless to us right now. This calendar year, because it's a surface sample, the 60 should translate to like 2010 because year zero in years before present is 1950. However, that information still isn't terribly relevant to us. So we are just going to highlight all this and delete it, shift the cell left. Okay. So we have the taxa names up here. Great. But we also have this stuff here in the middle that isn't really remotely useful for us. So delete these and shift cells up. Great. Now I notice that pH and water table depth are over here. So if you know how we set things up last time, we want our metadata to all be on the left side. So what I'm just going to do is insert a couple of columns and then control copy the column and then put it over here. Copy the data and put it over here. And then delete it from over here. And there we go. That's data that is in the format we want. Now, unfortunately, it's only one row of data, and we can compute our row total for all of this. That's not hard. But let's see if we can find some more interesting data. Let's take a look perhaps at some stratigraphic data. So I'm going to pause this and see if we can pull up some stratigraphic data. All right, so we have some more complicated data. This comes from a site it looks to be on the border between Georgia, the country, and Turkey. So we have our more complicated data now. You see, we have multiple species and we have some calibrated ages, and we have some gaps, and we'll be able to now do some nice transforms on the data. So let's start again by doing the transpose and deleting this. Control copy. Over here, skip a line, paste, paste special, transpose. Highlight this again. Delete, up, and that should get us most of the way. So let's just delete this. It'll shift it up. So again, we don't want this middle data. This is largely irrelevant to us. We just want the taxa names and the data. Delete. Okay. So name and analysis, these are probably not things we need, so we can delete them. Delete. Thickness, depth we'll want to keep, but thickness is probably irrelevant. It's all one. That sample number, again, we don't really need that. Sample ID, we don't really need that. Okay. Okay, so we have these data here, these calibrated ages. And so we would like to get them separated and then maybe eliminate them so that we only have one date to deal with. And we can't do that because we've got this data here too that is complicating things. So what we can do is we can go control copy, and then we go to the very end of the data frame, find the next open thing, and we're just going to paste that data here. Now, while it's still highlighted, we're going to go to data, text to columns, delimited. We're going to choose this as our delimiter. Click next, click finished, and we have now our 3 dates. So we'll probably want the one in the middle. So these are sort of upper and lower bounds to our data. We can keep them if that's part interesting to our analysis, but to me, I don't really think it is. So I'm just going to call this cal years BP. And then delete this. And then just delete this. And now this is metadata. And if you remember from last time, again, I still want all my metadata on one side. So I am going to just copy my data over here. Then I'm going to go back over here to where bacon was originally. And just Control V should do it. Yep. All right. or all my I could replace all my blank spaces with zeros here in Excel, but as it's only a single line of code in R, I'm just going to do it there. So, but we do want to make sure there are no NAs, no blank spaces in this data, and it doesn't look like there are. So now we have our depth, our age, and everything is in the format we want. So let's save this, and let's now turn to our studio and begin to bring in this data. So let's read in. I'm going to call it, I know it was on the Georgia side of the Turkey-Georgia border, but let's just call it Turkey. Because as an American, when I hear Georgia, I think of the state of Georgia. And so we're going to do import dataset from Excel. So I've cut out the part where you get to see my directory for privacy reasons. So we've got our data how we want it. Everything is double, which is an acceptable format for numerical with lots of NAs. So we're going to import that. And then I'm just going to copy this. And run this line again. All right, so we're good. Now, let's start by using our code to replace all the zeros. So again, in my general workflow, I tend to include my data processing here. We're going to do the same thing, except now we're going to do it with Turkey. So Turkey is na Turkey equal to 0. So this basically says for what are all the things that are not our NAs in the Turkey dataset? Give me those numbers, and then in the Turkey dataset, replace all those at those numbers with 0. We run this, and again, now we have zeros. Good. So let's talk about the issues we were having in converting counts to percent abundance data in one step. So I said that this function, count to perk, had this issue where it was inserting a column in between the metadata and the actual data, and it was throwing everything off. So I figured out that that was because when we were initializing the matrix, it puts a dummy column in the first spot, and then that appeared to be fine the rest of the way, but when you added metadata in front of that, it tended to screw things up. So I've solved that with a new function, C2P, same thing, count to perk. But what this does is it appends the data to the end of the original data frame, and then at the very end, it pulls the metadata and the new data separately into a brand new data frame if that's what you want to do. Of course, since you can leave it as is, I've given another default variable. I call this LA for leave alone. So just going back through the structure of this code here. Same syntax, the data frame, the position where our numbers start, our vector of new column names, whether we want to leave it as a percent or a decimal, and then whether we want to include the count data in our final data frame. So this just defines our dimensions. Here we supply some automatic data, we calculate our total, we compute the percents for each of the columns in our data, we add our names, and then if we want to, we strip the metadata and the newly calculated percent abundance data and combine them into a new data frame. And then if we don't, we just leave it as is because it's all right. So this should work. Let's try it. Let's go to data analysis, and right here, let's call this perk. Because I like rhyming, is equal to C P of Turkey. Now, we need that index for the first column of metadata. So, remember, in R, we count by starting at 1, unlike Python, where we count starting at 0. So, 1, 2, 3 is the first column of data. So, it's going to be the same thing here. Turkey, index 3. Now, when we run this, we don't get an error. And go up here to our things. Perk is the same size, so we're not adding an extra column. And we have it exactly as we wanted. So we've taken the raw data from Neontoma, we've processed it in Excel, we've further processed it in R, and now, at long last, we have it in percent abundance. So from here we can graph, but that will be a video for another time, probably.